Miss Marnick isn't here today, so you will be taking orders from me. Get out your math notebook and open to page 49. Do it now! All right, today we are talking about relating fractions and decimals. So turn in your math notebook to NF page 49. If you're not there already, pause the video until you get here. So what we're doing today is I can use decimal notation for fractions with denominators of 10 or 100. Fractions and decimals relate. They can be the same. So in our box here, we know a decimal is another way of representing part of a whole, or something that's less than 0. Decimals relate to fractions with denominators of 10 or 100 or etc. Today we're just going to focus on 10 and 100. A decimal point is used to separate the whole and the part. So these models below represent these fractions, and I'm going to show you how. We know our numerator is how many parts we're focusing on. So in this representation here, the shaded parts is what we're focusing on. So 1, 2, 3, 4, 5 is our numerator, what we're focusing on. Our denominator is how many equal parts are in the whole. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's divided into 10 equal parts. So that's the same as 5/10. Over here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this whole row is 10. So the numerator, or the part we're focusing on, is 10, 20, 30, 40, 50. And our denominator, how many equal parts are in the whole, is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 50 100ths. But you can see it's the same amount here, is the same amount shaded here. It's just the parts are divided into smaller parts over here. So it's an equivalent fraction. 5/10 and 50 100ths are equivalent fractions. When we're talking about it in decimal, there's 0 ones because the whole thing isn't shaded in either of our models. It's less than 1. So we have a 0 there. And then 5/10 is here. And if I just cover up the hundredths part, that would be 5/10. If I'm looking at this part here and it's 50 100ths, it's 0 and 50 100ths. So let's write the following as decimals. This is 4/10. So there's not a whole, so a 0 goes here. 4/10 goes to the tenths place, so it would be 0.4 is 4/10. If it's 40 100ths, there's still no whole, so that's a 0. But 40 100ths would go out to the hundredths place, 40 100ths. If it's 42 100ths, there's still no whole. But 42, this goes to the hundredths place. So 42 100ths. Turn your notebook to page 50. Flip to the next page in your notebook. We are on page 50 now. So for each of these models, we're going to write the fraction, the decimal, and then we're going to write it in word form. So let's start with the numerator, the part we're focusing on, the shaded part. In this model, 1, 2, 3, 4, 5, 6 parts are shaded for a total, if I know this is 6, 7, 8, 9, 10, a total of 10 parts. 6/10 as a decimal, that would be 0.6. In word form, we would say 6/10, T-N-T-H-S, tenths. Let's look at this model here. Focus on the shaded part. So this is 10, 20, 30, 40, 50, and then 51, 52, 53, 54, 55, 56, 57, 58. So the numerator, or the part we're focusing on, is 58. Our total is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So it's going to be 58 100ths, or as a decimal, 58 100ths. In word form, it looks like this: 50 hyphen 8 hundredths. Next model, we can see the part we're focusing on. There are 3 shaded parts out of a total of 10 parts, 3/10. As a decimal, it would be 0.3 or 3/10. In word form, we write 3/10. And last model here, I can see there's 10, 20, 30, 31, 32, 33, 34, 35, 36, 37 shaded parts, so that's our numerator, out of our total of 100 equal parts, so 37 out of 100. As a decimal, it would be 0.37. In word form, we would say it is 30-7 hundredths. All right, flip to your next page. Next page, 51. Hurry up. All right, we are now on 4NF7, comparing decimals. So before we were talking about decimals and fractions, now we're gonna compare decimals to see which one is bigger. You're on NF51, so if you're not there, get there now. Today I can compare two decimals to the hundredths place by reasoning about their size. So we use these symbols to compare decimals. We have greater than, equal to, and less than. Here's a tip for you and a hint for you here. When you compare decimals, you can think of them like money, like how many cents it is. And another way to do it is to make them have the same amount of digits. So here, this model is showing us 5/10. And here, this model is showing us 45 hundredths. Now, when I'm comparing, it can help if the tenths and the hundredths, if they're going out to the same amount of digits. So if I put a 0 here, now I have 0, so it's 50 hundredths, which I know is still the same amount as 5/10. Then when I compare, I can do 0, 0, same. Decimal, decimal, same. 5 and 4, 5 is bigger. So I know 5/10 is greater than 45 hundredths. It helps to have the 0 here because if 5/10 is greater than 45 hundredths. It helps to have the 0 here because if I just look at 5 and 45, it seems like 45 is bigger. But if I put the 0 to show what it really is, 50 hundredths, then I know that one's greater. Okay, one more page to go. Flip to 52. One more notebook page. Turn to 52. 52, I say! Okay, last notebook page of the day, NF52. Flip to that page, and we are going to compare each set of decimals. So we just learned that it's really helpful when we're comparing decimals if we have the same amount of digits on both sides. So 32 goes to the hundredths place. This goes to the tenths place. So go ahead and squeeze in a 0 there, because now it's easier to see 32 hundredths is bigger than 30 hundredths. Another way you can look at that is to do same and different, like we have been doing, 0, 0, decimal, decimal, 3, 3, 2, 2. We finally have a difference, and the 2 is bigger. So 32 hundredths is greater than 30 hundredths. Look at our next one, 0.5 or 5/10 and 5 hundredths. It's helpful if we make them have the same amount of digits. So I can't really squeeze in a 0 here, so I'm just gonna kind of cross it out and write this again. 50 hundredths, it's the same as 5/10. If I'm comparing 50 hundredths and 5 hundredths, I know 50 hundredths is bigger. So 50 hundredths is greater than 5 hundredths. Over here, 0.27 goes to the hundredths place, 0.7 only goes to the tenths place. To make it easier to compare, add a 0. Then I can easily tell 27 hundredths is going to be less than 70 hundredths, and I can put my less than sign. 33 goes to the hundredths place, and then the 3 just goes to the tenths place, so make them be the same, add a 0. Then I can easily see 33 hundredths is greater than 30 hundredths, and I can put my greater than sign. Last one, this one's nice and easy for us. We're comparing tenths place to the tenths place, so I don't need to change my amount of digits. I can just see 6/10 is less than 9/10 and put in my less than symbol. And there you go. We're done with the math notebook for today. Turn to your packet, and I will tell you which page we are going to start with. Okay, now, math notebook away, back in your binder. open up your Daily Common Core packet to the third page back that has fractions and decimals and models on it. It looks like this. Get there now! Okay, today we are turning our fractions into decimals, and we are comparing decimals today. So first, let's look at this picture. I can see that this whole is divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal parts. And this whole is also divided into 10 equal parts. I see that 2 of the parts are shaded. So my numerator, or the part that I'm focusing on, is 2. And my denominator, my equal parts in the whole, is tenths. Over here, I know my denominator is still tenths because it's broken up into 10 equal parts. And my numerator, the part that I'm focusing on, is 1, 2, 3, 4, 5. So this is 5 tenths. So I know how to compare these fractions. If I have 2 pieces of 10 and 5 pieces of 10, 5 pieces of 10 is bigger. So I'm going to put my less than side, so less than sign, so my alligator mouth.
Number 4.
100. So obviously this side is bigger, so I'm going to put my less than sign. If I compare the decimals, I have 89 hundredths and 98 hundredths, 0, 0, decimal, decimal, 8 and 9. 9 is bigger, so I'm going to put my less than sign. All right, one more. Over here, I have 19 shaded parts out of 100 equal parts. And over here, I have 20 shaded parts out of 100 total parts. I can see my 20. I have one more shaded in, so this one is going to be bigger. Now, if I look at my decimals, it's showing 19 hundredths and 2 tenths. This picture isn't showing 2 tenths, though. It's showing 20 hundredths. So I'm going to add a 0, and then I can tell 0, 0, decimal, decimal, 1, 2. My 1 is less than my 2, so it's going to be less than. And another way to think about it is 19 is going to be less than 20. All right, go ahead and flip the page.
Turn the page for your next task.
Okay, on the back, we are still comparing decimals, but this time we took the pictures away. So we're going to have to just look at the numbers. So what you want to do is the first thing you want to check and see is if your digits have the same number after the decimal point. So this has 2 digits after the decimal point, so it goes to the hundredths place. Over here, it only has 1 digit after the decimal point, and it goes to the tenths place. And we want both of our numbers to go to the same place after the decimal point. So to get this to go to the hundredths place, I'm going to add a 0, because 4 tenths is the same as 40 hundredths. And now I can compare each number. 0, 0, decimal, decimal, 3, 4. So 3 and 4 is where it's different, and 4 is bigger. So I'm going to put a less than sign. This means 35 hundredths is less than 40 hundredths. Over here, I can see my first number goes to the hundredths place, and my second number goes to the hundredths place. So I don't need to add any zeros, and I can just compare. 0, 0, decimal, decimal, 0, 6. That's where it's different, and 6 is bigger, so I put less than again, because 6 hundredths is less than 60 hundredths. Number 3, my first number goes to the tenths place. My next number goes to the hundredths place. So I'm going to add a 0 to make both numbers go to the hundredths place. Then I can compare. Like I was doing before, I can go 0, 0, decimal, decimal, 3, 0. 3 is bigger and put a greater than sign. Or I can think 30 hundredths is more than 3 hundredths, and that's why I need my greater than sign. Let's try it with number 4. I can see that this goes to the hundredths place, and this goes to the hundredths place. So I can just think, okay, what's bigger? 42 hundredths, or 42 shaded out of 100? Or 24 hundredths, 24 shaded out of 100. 42 hundredths is my bigger one. So 42 hundredths is greater than 24 hundredths. For number 5, my first number goes to the hundredths place. My second number goes to the tenths place. So I'm going to make them both go to the hundredths place by adding a 0. And now I can think 69 hundredths or 60 hundredths, which is more. More would be 69. So 69 hundredths is greater than 60 hundredths. Number 6, both numbers go to my hundredth place, so I don't need to add a 0. And I can just think 50 hundredths or 38 hundredths. 50 hundredths is going to be bigger, so 50 hundredths is greater than 38 hundredths. All right, number 7, I have tenths place and hundredths place, so I'm going to add a 0 to make them both go to the hundredths place. This time I have 80 hundredths compared to 80 hundredths. They are equal, so you should put an equal sign there. And number 8, 25 hundredths and 35 hundredths. 35 hundredths is bigger, so I put 25 hundredths is less than 35 hundredths. Okay, let's try it with some word problems. So we have Billy has 56 hundredths of a dollar in his pocket. That's like saying Billy has 56 cents in his pocket. It's just in decimal form. Jesse has 6/10 of a dollar in his pocket. When we say 6/10, if we're thinking it in decimal form, it would be 0.6, 6/10. And that's like saying, not that he has 6 cents, but like he has 60 cents if you add a 0. So 60 cents is right here. The question is, who has a greater amount of money in his pocket? So if I put these numbers next to each other, 56 hundredths and 6/10, which you saw I changed it to 60 right here to make it 60 cents. Here's why. If this goes out to the hundredths, this has to go out to the hundredths, and I have to put a 0 there. So I'm comparing 56 hundredths and 60 hundredths. 60 hundredths is going to be bigger. So the person who had 60 hundredths was Jesse, and he really had 60 cents. So who has a greater amount of money? Jesse has a greater amount. Let's look at number 10. Fiona paid 68 hundredths of a dollar for the pencil. So write it out in decimal form. 68 hundredths would look like that. That's just a weird way of saying 68 cents. She paid 83 hundredths for a pen. So 83 hundredths would look like this. 83 hundredths, and it's just a weird way of saying 83 cents. The question is, which cost more? So let's put these numbers side by side and compare them. We have 68 hundredths. That was the pencil, so I'll label it pencil. We're comparing it to 83 hundredths, or 83 cents, that she paid for the pen. I can see that out of 68 hundredths and 83 hundredths, 83 hundredths is greater. So which cost more? I'm going to write on the line, the pen cost more. Number 11. The book is 16 37 hundredths centimeters long. The laptop is 16 8/10 centimeters long. Which is longer? So if I put these numbers side by side, 16 37 hundredths, that's the book, and 16 8/10, that's the laptop. And I can see that 37 goes to the hundredths and the laptop only goes out to the tenths. So I'm going to add a 0 to make them both go to the hundredths place. And then I'm going to compare 1, 1, 6, 6, same so far. Decimal, decimal, then I have 3, then I have 8. So this one is going to be bigger, 16 80 hundredths. So the question is, which is longer? The laptop is longer. All right, one more on this page, number 12. The sandwich costs $4.73. Another way to think of that is 4 73 hundredths. The salad costs $4.39, or 4 39 hundredths. Question, which costs more? Write them side to side. We have $4.73 for our sandwich. We have $4.39 for the salad. Then compare 4, 4, decimal, decimal, 7, 3. The 7 is bigger. So my sandwich is going to be bigger. Write the answer in a complete sentence. Which costs more? The sandwich costs more. All right, flip to the next page.
Turn the page again. Quickly!
Okay, your next page looks like this. If you look down at the bottom, it has a number 94 on the bottom, so get yourself there. We are going to compare fractions and decimals. So number 1, I have 3/10 equals something out of 100. So think of how we make equivalent fractions. We can make an equivalent fraction by multiplying by 1 whole. So this went from 10 to 100. To get from 10 to 100, I need to multiply by 10. To multiply by a whole, I need to multiply by 10 over 10. So 3 times 10 is 30, and I get 30 hundredths. If I look down here, 3/10, that matches that, and it equals 30/100ths. And we know that's true because I could just put a 0 here, and 30/100ths would equal 30/100ths. So let's create an equivalent fraction over here, 4/10 to get to hundredths. To get from 10 to 100, I need to multiply by 10 over 10. 4 times 10 is 40, so I get 40/100ths. Now I'm going to write the decimal. 0.4 is 4/10. 0.40 is 40/100ths. All right, 71/100ths to get to something over 10. This time I'm going from a bigger number to a smaller number, so I'm going to need to divide by 1 whole, or divide by 10 over 10. This is when my zeros cancel out. So 70 has a 0, 10 has a 0, those cancel out, and it becomes 7/10. Because over here we have a 0 and 100, and a 0 and 10. There's 1 0 left, and we get 10. So over here, my fraction 70/100ths would look 0.70 as a decimal, and 7/10 would be 0.7. 70/100ths is the same as 7/10. Number 4, 51/100ths to something over 10. So again, I'm going from bigger to smaller. So I need to divide by 10 for this one, because 100 divided by 10 equals 10. So 50 divided by 10, the zeros cancel out, and I get 5 for 5/10. Change it to decimals, 50/100ths would look like 0.50. 5/10 would be 0.5. 6/10 to something over hundredths. 10 to 100, it's getting bigger. So I'm going to need to multiply. 10 times 10 equals 100. So if I multiply by the whole, 6 times 10 equals 60. 10 times 10 equals 100. Write our decimal equivalents. So 6/10 looks like that, 0.6. 60/100ths would be 0.60. All right, number 6, 90/100ths. We're changing it to something over 10. So my number is going from 100 to 10. It's getting smaller. I'm going to need to divide by my whole, which is 10 over 10. The zeros cancel out. 90 divided by 10 equals 9. And then my zeros canceled out on the bottom too. 1 0 here, 1 0 there. That's how I end up with 10. So 90/100ths would be 0.90. 9/10 would be 0.9. All right, try the rest of this page, 7, 8, 9, 10, 11, 12 on your own. Then come back and check your work and see if you got it right. So go ahead and pause the video. Okay, here are the answers for the rest of the worksheet. Pause this video and check your work carefully. Make sure you multiplied when your number was getting bigger and divided when your number was getting smaller. You can see here for number 7, I tried to fly through and I had to cross it out because I started to multiply and then I realized I was going from 100 to 10, so it's getting smaller. I need to divide. So check your work for these problems. Great job if you got them all. When they're perfect and match my page, you can move on to the next page.
Next page. Do it now.
All right, we've got some word problems on the back. Let's solve them together. Before you start underlining anything, really read the whole question like we practiced to understand. Read it and visualize before you start underlining important info so you know what you have to figure out. Number 1, each question on the test is worth 10 points. Lola got 9 out of 10 answers correct. Write a fraction and a decimal that show the portion of the test she got correct. So we always bracket the question. This time there isn't a question. It's not asking us what to do, it's telling us what to do. And it's telling us to write a fraction and a decimal that show the portion of the test she got correct. So here's what we need to pay attention to. We need to write a fraction, we need to write a decimal, and the part that we're focusing on is what she got correct. So our correct part is going to be our numerator, which we know is the part we're focusing on. So all we need to know here is that she got 9 out of 10 correct. So each question on the test is worth 10 points. We don't need to multiply here or anything because we're just writing a fraction and a decimal. So 9 is how many she got correct. That's the part we're focusing on. It's our numerator. Denominator is the total questions, or how many equal parts are in the whole. So that's our denominator. So when I write this as a fraction, I'm going to write 9 out of 10. Have you ever seen that on the top of a test before? 9 out of 10 correct. That is what it would look like as a fraction. We also want to write it as a decimal. 9/10 is the same as 0.9. 9/10. And there you go. That's all you have to do. Let's try number 2. Same thing. Don't underline right away. Just figure out what the question's asking, or telling us to do in this case. Lex has 10 pages to write for his history report. He has written 7 pages so far. Write a fraction and a decimal that show the portion of the report that he still has to write. So first, bracket the question, or in this case, bracket the thing it's telling you to do. We need to write a fraction. We need to write a decimal. And we're looking or focusing on the part that he still has to write. So it's not the part that he already has written, but what he has left. So if you see something like still has to write, it's a hint word for subtraction, because it's another way of saying how many does he have left. So we know he has to write 10 pages. That's the total of pages, total number of pages he has to write. So that is going to be our denominator, or our equal parts in the whole. We know that he's written 7 pages so far, but that's not my numerator. That's what he has written so far, so that's not what we're focusing on. What I'm focusing on is what he has left to write, what he still has to write. So I need to take my total number of pages, 10, and subtract how many pages he's written so far. 10 minus 7 equals 3. This is my numerator. That's how many pages he still has left to write. So my numerator is 10, the part we're focusing on, how many he has left. My denominator, or my equal parts in the whole, is 10. So my fraction is 3/10. As a decimal, that would be 0.3, or 3/10. Let's look at number 3. Just read it first and figure out what you need to do before you start underlining. Paige has 100 pennies. She gives 50 cents to her brother. Write a fraction and a decimal that show the portion she gave to her brother. So here is our question, but not really our question because it's just telling us. We need to write a fraction. We need to write a decimal. The part we're focusing on is what she gave to her brother. So we know she has 100 pennies total. That's our equal parts in the whole, or our denominator. 50 cents is what she gave to her brother. That's the part we're focusing on, our numerator, 50 cents. Another way of saying 50 cents is like saying 0.50, because we put cents in decimals. That would be 50 cents, or 50 hundredths. So my numerator is going to be 50. My denominator is 100, 50 hundredths, and that makes sense because I wrote 50 cents in standard form over here. So my decimal should match that, 0.50, 50 hundredths, or another way to write this is 50 cents. All right, number 4. Miss Marco is on a 100-mile bike ride. So far, she has ridden her bike 40 miles. Write a fraction and a decimal that show the portion of the bike she has left. So bracket what it's telling us to do. We need to write a fraction and a decimal, and we're focusing on the part of the bike ride she has left. So we're going to need to do some subtraction. We don't want to know how many she's done so far, but how many is left. So we know a 100-mile bike ride. That is our total number of miles. That's our denominator, our equal parts in the whole. So far, she's ridden 40 miles. But we don't care about how many miles she's ridden so far. We want to know how many she has left. So we're going to have to take our total number of miles, which is 100, subtract from the miles she's ridden so far, 100 minus 40. That equals 60, if you can do some quick mental math in your head. This is the part we're focusing on. That's our numerator because it's how many she has left. So our fraction is going to be 60 over 100. Our decimal is going to be 60 hundredths, 0.60. All right, now we have some multiple choice. So we don't have to come up with the answer on our own completely like up above. Now we just have to figure out which the best choice is. So let's read the question. 1 meter is equal to 100 centimeters. You should be saying in your head, you should be seeing meter to centimeters, and you should be saying, uh-oh, it's a conversion. And it's actually telling us our conversion right in the problem. We don't even need to go to our math notebook and flip to our formula sheet. So right away, I'm actually just gonna box this in like my sticker, because this is what I'm gonna need to write down. 1 meter is equal to 100 centimeters. But let's keep reading before I start solving. Olivia's desk is 80 centimeters long. The question is, which decimal shows the length in meter units? Let's tackle this like a conversion problem. We drew our box around the sticker part. 1 meter is equal to 100 centimeters. Peel off that sticker and write it. 1 meter equals 100 centimeters. Draw your input-output table. We know that Olivia's desk is 80 centimeters long, so it's going to go on the centimeter side, 80 centimeters. We don't know how many meters it is, and the question is asking us which decimal shows the length in meter units. That's why we need to do a conversion. So I know every input-output table has a rule box, so I'm going to draw it in. I'm going from 1 to 100. I know in conversions it's always multiplication, and it's multiplication by the number that is not 1. So in this case, it's times 100. So we have a missing input, something times 100 equals 80. If I have missing multiplication, I can solve that with the inverse operation of division. Now remember, in multiplication, your total is always going to be at the end. In division, your total has to be at the beginning. So we're going to start with 80 divided by 100 equals, and then we'll get our answer right here. Now, 80 divided by 100, we know fractions are division. So 80 divided by 100 is just another way of saying 80 100ths. So we have that. If we want to do it in our calculator, if you type in 80 divided by 100, you're going to get an answer of 0.8. And that's what we're solving on the meter side. So that's 0.8 meters. Okay, so let's look at our choices. A is 80 out of 100 meters, or 80 hundredths meters. Now, we have the decimal as 0.8 meters, so that doesn't match. But we did see here 80 100ths meters is the same as 8 tenths meters, so I'm thinking it could be that. But let's check the other ones just to see. 8.0 meters? No, it's 0.8, so it can't be B. 0.8 meters, ooh, it could be this one, because 0.8 meters, that matches our answer that we got. 0.08 meters, or 8 hundredths meters, does not match. So it wants to know, we have two answers that could be right, because we did 80 out of 100, or 80 hundredths, as the fraction, which is the same as 8 tenths meters. Pay attention to your question. It's asking which decimal shows the length in meter units. 80 100ths is a fraction, not a decimal, so it can't be that, and our choice has to be C. This is a great example of how problems try to trick you. So pay attention to all of the directions and everything you need to do to get the right answer, because if you circled A, even though you're technically right, it's not the best answer and you would be wrong. Make sure it's C, 8 tenths meters. Look at number 6. This is another one that's trying to confuse you with extra information. So let's read it first. Philip has $10. Each dollar is worth 100 pennies or cents. If he spends $1, write the decimal that shows the amount he has left. So bracket the question, or in this case, what it's telling us to do. Write a decimal that shows the amount he has left. We know left means we're going to have to subtract. So we need to know what he has. We know Philip has $10. So that's like in standard form, $10 is $10.00. We know he spends, that's what we're going to subtract, $1, which is $1.00. So if I have $10 and I subtract $1, doing subtraction here, 0 minus 0 is 0, 0 minus 0 is 0, 0 minus 1, more on the floor, go next door and get 10 more, change this to a 10, 10 to 1 is $9, so he has $9 left. So the only one here, 9.00, it has to be this. That would be 9 hundredths, 9 tenths, 99 hundredths. We know he has a full $9 left, 9 whole dollars left. So the 9 is a whole number, and it's $9. This each dollar is worth 100 pennies is just extra information to try to confuse you. So don't get tricked. Your answer is D, 9 or 9.00 or 9 wholes, or it should really have a dollar sign here since we're talking about dollars, $9.
Now you may turn to the first page in your packet and watch the rest of this video to help you with your daily Common Core.
Here we go. Let's take a look at Daily Common Core number 83. Number 1, put the numbers in order from least to greatest. So you should know that means smallest to biggest. Take a look at these numbers, compare them, and write them in order on the line. Number 2, if there are 13 trays, how many muffins are there? So this is an input-output table. It is going horizontally. You need to look from input to output, or from muffins to trays. So we know there are 13 trays, so we know something on the tray side. We have a missing input on the muffin side. So look from input to output, draw your arrow going up or down, find your rule, and solve that missing part. Okay, number 3, 50 shirts and 15 pairs of pants come in each box. If there are 400 shirts in all, how many boxes are there? So make sure you bracket the question. We're looking to see how many boxes there are. There are 50 shirts in each box, so I-E-G, in each group. And there are 400 shirts in all, so that means 400 is our total. Now, in all could mean add, or it could mean multiply. I'm seeing that I have in each group, so I'm guessing in all is going to mean multiply. Now, it says 15 pairs of pants, but we don't care about the 15 pairs of pants. We just want to know how many boxes there are. We know our total, and we think in all means multiply, but if we know our total, it can't be multiply. It actually has to be division. So we're going to set this up as total divided by groups equals how many are in each group. So this is an example. Don't let those hint words trick you and make you think it's multiply. If you know the total, which is 400, and you're dealing with groups, and in each group, you know you're going to have to divide. So set up that equation, write your sentence on the line. Number 4, what number is a factor of 295? We know factors are the numbers that multiply together. So something times something equals 295. So we can start by checking 15 times something equals 295. You're going to need to do the inverse operation of a division to solve that. Write your evidence next to it and circle the correct answer. All right, let's try number 5. It says, move the camera a bit. There we go. Draw a line with a point on the left labeled 2 and a point on the right labeled 3. Draw tick marks to divide the line in 8ths. So we need to draw a line. We have to have a point that has 2 and a point with 3. So I'm going to start out by drawing my line. I know a line is a straight line that goes on forever in both directions, so I need to have arrows to make it a line. If you don't have arrows, you didn't draw a line, so put those arrows on it. Then I'm going to put a point on the left that says 2, like the directions say, and a point on the right that says 3. And then I'm going to put my pen down and do this part in pencil so I don't mess up. I need to divide the line into eighths. So I need to think, if I'm going into eighths, do I need to split it into thirds, or do I need to split it into halves? So if I have the fraction 1/2 and I multiply it by 2/2, it would be 2/4. And if I multiply it by 2/2 again, or 1/2, it would be 4/8. So if I split it in halves, I'll be able to get eighths. So I'm going to find the halfway point between my 2 and my 3. I think it looks like it's about there. Now I have, you know what, see, this side looks a little shorter. So I'm going to erase as good as I can and try to move it over a little bit. Put it there. That looks a little closer to halfway. Then I'm going to, I have 2 parts. I'm going to double them. So with a little bit of a shorter line here. A little bit of a shorter line here. Now if I look, I have 1, 2, 3, 4. I need to get to 8ths. So I'm going to double it again with an even shorter line. Boop. Double each piece. And then 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 parts, so I'm going to move back to my pen because I'm confident that everything is equal parts. And it says label 2 and 2/8. So here's 2. This would be 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8. And I need to label 2 and 2/8. So this is 2 and 1/8, 2 and 2/8 would be right here. And then it wants me to create an equivalent fraction, which I know is an equal fraction made by multiplying or dividing the fraction by 1 whole. So I'm going to ignore my whole here, my 2. I'm just making an equivalent fraction to 2/8. There's a couple ways I could do this. The easiest way to make an equivalent fraction is to multiply by 2/2. If I do that, I get 4/16, and there's an equivalent fraction. Or maybe I don't want to multiply. Maybe I want to take 2/8 and I want to divide by 1 whole. Let's say I want to divide by 2/2. 2 divided by 2 would be 1. 8 divided by 2 would be 4. And I could get an equivalent fraction to 1/4. So I only needed to do 1 equivalent fraction, but I actually did 2. 4/16 and 1/4 are both equivalent to the fraction 2/8. All right, number 6. Holly bought 2 boxes of pencils. One box had 24 pencils in it. The other box had 36 pencils in it. She gave 18 of her pencils to Zach. How many pencils did Holly have left? First, bracket the question. We want to know how many she had left, so I know I'm going to be subtracting. I know one box has 24 pencils in it, so that is a part that I know. We know the other box had, so other box, 36 pencils. That is another part that I know. And then she gave 18 pencils to Zach. So that is another part that I know. So first, I'm going to have to find my total number of pencils by adding up the 2 parts, 24 and 36. Then I'm going to have to subtract the total from the 18 that I gave to Zach to get my final answer. So do those 2 steps and write your sentence on the line. All right, you can move on with Daily Common Core and finish this page on your own.
Once you have finished Daily Common Core on your own, you may complete the rest of the packet. If you are done with your entire packet, put it in the important side of your binder and use your time to first do extra math, then do ST math, and do not disappoint me.